Hey there, this is Scott Forbes with Pacifica Science. I always wanted to roll in like John Green does for his videos with Crash Course, but that's probably the closest I'll come. Okay, if you check out Pacifica Science right here, the notes behind me on the board are designed to go along with the lecture that we did in class today and our notes. And we're basically going over how we're adapting this experiment to do it at home. Again, we don't have all the resources at home probably that we have here in the classroom. So we're going to show you some of the things that we changed and what it would look like were we actually here in the classroom. Let's jump right in. And if you check out this looks a little bit like yesterday's video. If you saw it, we have a pendulum swinging on a string. And we're going to talk about how we know when we're doing an experiment if our independent variable, the one that we're changing, the one that we're choosing to change, is affecting the dependent variable, the thing we want to check out. One of the examples that we gave here in class today was Starbucks, of all things. I went to Starbucks down at Linamar this morning, picked up a mocha, kind of an indulgence, I know, but when I pick up a mocha at a Starbucks, it could be the Starbucks in Linamar or it could be a Starbucks in New York City. I expect it's going to have a certain taste. If you look at controls in an experiment, again, this goes along with our notes, which are already posted out there, so I won't go into huge detail about controls, but they're the things that you want to keep track of and you want to keep consistent time after time in an experiment. When you look at a restaurant like Starbucks, McDonald's, Chick-fil-A, pick your place that makes food, whatever it happens to be, what they do very well is control the variables in their cooking, chemistry. They want to make sure that every time you order whatever it happens to be at one of their franchises, at one of their restaurants, it pretty much tastes exactly the same. You get the same experience whether you're in New York or halfway around the world. So the point with experiments, it's the art of experimenting really, is to make sure that you're controlling variables as much as you possibly can is the same. One of my very, very favorite experiments that I would show in class at this point, and I'll show you a couple clips from it with the notes at some point this week, was the Mythbusters, the great, wonderful Grant Imahara, along with Tori Valenci and Carrie Byron did one where they were testing baseballs, and they had the baseballs that were, some were very, very, very humid. They were kept in a more humid environment. Some were drier, and they wanted to see the distance that the baseballs went when you hit them with the bat. They did a fantastic job in that experiment of controlling the variables. So I want to do a shout out to the Mythbusters in that particular one. And as you may or may not know, Grant Imahara unfortunately just passed away, but he was an absolutely excellent experimenter. He really did a fantastic job of keeping things consistent from experiment to experiment. All right, so let's jump right in. If you check out very, very quickly right here, a pendulum with a mass swinging, we wanted to check out. Hopefully you kind of remembered from our lesson on Galileo what probably should have happened. We want to see if changing the mass affected the swing time of our pendulum. Now, swing time isn't really a term that we use in science. It's really the period of the pendulum. Swing time sounds more like something you might hear with Louis Armstrong, but in this case right here, we're talking about how long it takes to go all the way out and all the way back. Were we in class, I would have given you a mass, like we did here, and with the mass, we would have weighed them. Now I went ahead and already weighed the two masses that I used today. One weighed, the lighter one, 10 grams. The other one weighed 30 grams. And if I'm looking at mass, that's what we're changing. We're changing the mass of our pendulum, of the thing hanging from the end of the string, and we want to put that all on the x-axis. Remember, the x-axis is where you want to put your independent variable. We want to see what happens to our dependent variable, which we're putting up on the y-axis. In other words, we want to see if we make a change here, does it affect anything there? Let's find out. The students were asked to check this out using my very complicated stopwatch. Now, stopwatch here is really just my old iPod, and what I'm going to do is I'm going to pull it back, and I'm going to be consistent about the distance with which I pull it back. Let's look at the things that we want to be consistent about here. We want to make sure the string is the same length, a control variable right there. We want to make sure that we pull it back the same amount each time. In physics, that would be considered the amplitude. We want to make sure that we pull it back the same amount each time. For my purposes here, I'll be pulling it back 20 centimeters, which I've measured to the end of the chair. Your challenge here was, what's one other, there's dozens of them you could come up with, but what's one other control we could list for this experiment? What's one thing that you want to keep consistent every single time? Remember, ideally you want to control all the variables except the one that you're testing. So let's check this out. We're going to pull it back to the end of the chair. I'm going to start my stopwatch, stopwatch right when it starts to swing. The reason I'm doing that, it's really hard to time just one swing, so I'll time 10 swings and then divide by 10. Really easy to divide by 10, you're just hopping a decimal place. And go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 swings, looking at that right there. 13.6 seconds. Hop in a decimal place, that means each swing took about 1.36 seconds. Looking right here, this is the heavier mass. 30 grams is the heavier mass. 1.36 would be roughly there. It's a dot on our graph. The nice part about doing these experiments is that you get to very, very easily see with just simply looking at a graph, is there a connection between the one thing you're changing or not? I'm now gonna tie another string up here. This is what we did online in class day. Now remember, the students when they were doing this, were just doing this watching online. And the reason I tied it was because I wanted to be as close as I could to exactly the same length, which is there. What I'm going to do to keep this other one out of the way in just a second, I'm going to step off the screen for a split second, which I did in the class. I'm just going to take down the other one. But if you look at it as it's hanging here, they're both just about 40 centimeters. Be right back. Back with my trusty scissors, which I should have had handy, and I'm going to cut this one off completely. Leave this one hanging. The lighter one now. Now the lighter one again is, let me cut this off. The lighter one is 10 grams. We tested 30 grams. Each swing for 30 grams took about 1.36 seconds. Let me reset the, excuse me, let me reset the timer and do it one more time. Reset. So we've got a reset timer and pull it back and go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see. Honestly, just hit stop. 13.6, 1.36 seconds. It's kind of amazing. You usually get great results like that. In other words, for 10 grams, 1.36 seconds, something, oops, that should have been a little bit higher, around there. Something like that. The point being this, hopefully we remember from our studies at Galileo just the other day that different objects, when they're different masses, if they're roughly the same shape, they fall at the same rate. If you look at this right here, this is really just falling. Pendulum is just slowing down the falling. Galileo did this really cool thing where he used ramps. It was a way to test falling, but slowing it down so he could observe it more closely. We're doing the same thing here. If you're going along and graphing your data, right now we just have 2 data points. But if you want to get as many trials as you can, iterations of the experiment, you want to keep checking by changing the masses. That's your independent variable. You have the independence. You have the choice to change the mass. You could use 10 grams, 50 grams, 1,000 grams, a kilogram. And as long as you kept the string length the same, as long as you control for all the other variables, ideally, we should pretty much have a straight line here. In other words, all the dots should connect to make a horizontal line. What that's telling us, and again, we'll go into this in more detail over the course of the week, what's that telling us is there is no connection between the mass and the period, the swing time, the time it takes to go all the way out and all the way back. Try it yourself. We set this up at home. I'll revisit that experiment at home where I had the two silly looking weights hanging from my rafters in the garage. We're up to our 10-minute limit. Have yourself a great day, and we'll jump on into the notes online. Take care. Bye-bye.